Delegates represent a functional programming paradigm known as function as a value. And you're using it whether you're aware of it or not. And if you're not using it, you most certainly rely on it in one way or another. That's why I think it's important to know the concept behind it, and then secondary, the syntax in C# so you can actually write the thing. I know some programmers fail to see the value behind it, so hopefully today I will be able to relay to you why delegates or functions as values are valuable, and then we're going to take a look at some behind the scenes of the delegates in order to understand potential overheads and a little bit closer to what they actually are. So let's dig in. Let's begin with explaining the idea behind the function as a value. So how you usually store descriptions. So I'm a human being, right? That's a description. I have long hair and a black t-shirt. So those are objects. You can classify them as fields, and you store a color like black in a variable. How about instead of descriptions, we go ahead and store functionality, doing something like running or taking things out of the box and putting them into a bigger box. Why can that not be a variable? Well, that's precisely what it is. It's basically taking functions and putting them on the same level as normal variables. Okay, why is that useful? Let's say I am going to the beach. Many people go to the beach, and when I go to the beach, I like to drink water. Who am I kidding? I drink beer, right? Some people drink water, I drink beer, kids drink lemonade. Okay, so there's 3 things we can consume on a beach. Let's go ahead and write this up. First, I'm gonna write up the 3 beverages that you can drink. So public void drink water. And I know this is a really simple example. If you're looking at this doesn't make sense. I can write it like this. Imagine that this is a more costly operation rather than just printing a string. Okay, try not to fight the example. Try to understand the concept behind it, and that you can substitute the drinking or rather printing of a string by anything else. Okay, so drinking water. And if you're also wondering what is this IDE I'm using, this is called LinkPad, and this is not really an IDE. This is like a sketchpad, a script. You basically write C# scripts with it, kind of like you do in Python. And it's just a really neat way to quickly show concepts or proof of concepts and stuff like that, or write up scripts so you can reuse, right? Anyway, link in the description. At the moment, we're just printing out stuff, right? So drinking lemonade. Here we're going to be drinking beer. Let's move this over. And if you're wondering about what the dump method does, what it does is essentially just output stuff to the right side here. Okay. So let's go ahead, output this a couple of times. We're going to be drinking water, drinking beer, and we're going to be drinking lemonade, right? So there is 3 things we can do. Okay. Again, if you're struggling with the example that we're just outputting a string, imagine you have an entity and you're saving it to a database. You may be saving it to Redis cache store. You may be saving it to an SQL store. You may be saving it to document storage. Each one of those is going to look differently. Imagine this is a storage operation if you'd like, but for now, we're going to keep it simple. Now, let's put myself in a scenario where I'm going to be present somewhere or doing something. And I spelled beach wrong. Beach. Okay, so I'm relaxing on a beach again. Let's say I just want to be relaxing on the beach. Some people, they relax on the beach and drink water, which is where we're going to drink water. Some people are going to be relaxing on the beach and drink beer. Okay. And hopefully you see the point here. 4 functions just to sort of output this and, drink some water. And again, I'm gonna stop. This is the last time I'm mentioning. If you're like, well, we can put a string and just dump the string here if it's not null. Imagine this is a bit of a more complex operation. Okay, let's go ahead and do something a little bit more different. The first thing that I'm gonna I'm gonna do a little detour before jumping into delegate syntax straight away. I'm gonna expose what they are first as a single method interfaces, as a way to think about them. Let's do this. Let's create a public interface and we'll call it iDrink. So we might do something like have a little drink function, put void here. Okay, and we do public class drink water, and I'll just put O here for object, right? And this is going to inherit from iDrink. Very verbose, a lot of things. Yeah, let's go ahead and drink water, and then I can do the same thing for other methods. Hopefully you get the picture here. So we're getting this explosion of classes here if we want to do it. So drink water, drink beer again. But what we get with this implementation, let's actually follow through with it. I think it will be worth seeing this transformation. Water, lemonade, and perhaps what we can do is maybe point to these things. we won't be able to grab out our scope. That's maybe just me derping around, but yeah, so we got these objects now. So what we can do now is we can delete these specific implementations and we can pass an iDrink interface. And what we can do is, well, if drink doesn't equal null, let's go ahead and, drink the drink. Cool. So now whenever we're gonna go and relax on the beach, we can, which object do we want? We can either pass null, and then we're not gonna drink anything. Just forgot the semicolon there. Let me comment this stuff out. We can create a new drink water object. Okay. And that's kind of what a delegate is. But at the moment, what we're doing is we had to create an object for each one of these and define an interface to be able to substitute what action or what thing we want to do. So the thing that we want to do is hiding inside an object. Okay. Delegates, functions as values are still those same objects. Although an object is kind of misleading way because the object exists purely for the existence of this function. Okay, so all this thing right here that I'm gonna like move out, this is the important stuff that I'm highlighting. This gunk, this class, we don't need to know about. We don't need to know about this thing right here. So all of this is just muda. It's nothing. We don't need to know this. Okay. What's important is the thing that we're trying to do. The class around it, it's just a place that holds it. It doesn't add value to like the reading of the code. And this is partly what it's about. It's about readability and intention. So we now come up with a syntax of delegates where it's important to understand the syntax. If you're struggling with the syntax of delegates, it's important to understand what a signature is. A signature of a function. I'm going to explain that to you. Okay, so drinking action, we're going to define it. And this is going to look, let me cut it, let me bring back all my objects. And I'll just put it here. This is a signature. This is what a signature is of a function. It's the return type and the parameters. That is what allows you to align functions. Okay, to align functions. If a function has the same form, and the form is having an identical signature, so void and 0 parameters, same signature. Void, no parameters, same signature. The name doesn't matter so much. It's all about the return type and the parameters. Okay, that is what's called a signature. As long as these match, you can fit this interface. Okay, you can think another way. You see the thing that we define here? This is what you're defining here without an interface. So the delegate is the method on the iDrink interface, and that's what C# gives you behind the scenes, which we'll explore in a second. And then it also gives you this object, in which case you just need to provide its implementation sort of thing. So now that we understand that this delegate, the interface for a function that we define here, is just this thing here, we can go ahead, I'll remove this again, and we'll say, okay, we are expecting this interface here. So instead of this object, I'll just need to make this public real quick. Okay, so instead of the object, we will need to put in a function. I think we do. So instead of calling, remember, if we call a function, we're really evaluating it to void. Okay, so what we have to do is we have to pass the actual function. See how we're not calling, we're not putting braces there in order to invoke the function? We put it here. Okay, so once we have the drink, we can just go ahead and call it like this. All right, so you can see how much less syntax we have, and we can go and relax on the beach and drink specific things. Okay, and we can go ahead and be on the beach and drink lemonade. We can do all of these things. And if we go ahead and we want to, you know, running 10 miles, we want to go ahead and, you know, run and drink beer, we can do that as well. So you can see how we are, the reusability of code is like marginally increasing. It's skyrocketing without actually having to introduce a lot of code ourselves. And this is what delegates do. They're going to shrink your code base, and they're going to give you more readability. The less you have to read, the quicker you can understand your code. Okay, now let's take a look at two kids of delegates, func and action, and we'll take a look at how we can use those. And actually, before we do this, an idea just struck me. It's probably worth showing that what we can do is we can actually just say var drinking action. So a variable will equal a new drinking action. Okay, and the constructor itself will take a parameter of the action, right? So we're literally creating the interface kind of thing, and then what we can do is we can say drinking action and just invoke this function. Okay, so this would create the container in which the function goes. All right, now we can kind of recognize that it's an object that just sort of contains the implementation, and that the primary usage of it is readability and reuse of code. We can now take a look at func and action. So func will be really easy to understand once you get it. Let's take a simple example of adding two things. So we say we want to add, and this will be actually I'm kind of gonna be introducing lambdas here. I think it will be okay if we learn about lambdas here as well. So let's say a plus b. So if we call add 1 + 1, we dump it, we're gonna get 2 in the end. Okay, so let's go ahead and just comment this stuff out here. And drinking action as well, we don't really need it. You can see the 2 being printed. I'm gonna go ahead, press F12 here, so I want to take a look at what a func is. And as soon as this pops up, there we go. Hopefully you can see this. Can I zoom in? That's a search. I'm afraid I can't do much, but hopefully you can read this. Delegate, T result, func, and this is really where you kind of gotta know generics. If you don't, I'm sorry, I'll make a tutorial on generics as well. But the signature is T result. It's kind of defined here, and then the arguments are T1 and T2. A func is just a generic delegate, okay? And same for an action. But the primary difference between a func and an action, sorry, let's say we'll put int here, and we're gonna say print number equals, what we say, we supply a number, and then we just go ahead and dump it. Okay, so let me just put this down on a new line here. Again, action is not a breakpoint. We're going to take a look at what an action is, and an action is, again, It's just a generic delegate. The main difference between func and action is func has a return type. Okay, so a function has to return something, and action is a delegate that's void, so it doesn't have to return anything. Its signature starts with void, and then all of it is just parameters. As you could probably imagine, defining your delegate like this and then having it basically, if I have this in another file, let's simulate that by putting it up here. If I look at this, I don't know the signature of the function. I don't know what it does. So I have to go to this function and I have to take a look at it. Okay. What we can do is, because the signature is void to start with, we're going to use an action. We can go ahead and say action, and it supplies no parameters, so we don't have to specify a generic type. And this is all still valid code which we can trigger. Okay. If we want an action that takes parameters, we then specify an integer. If we want to add more parameters, we will have to kind of wrap it like this, but hopefully you get the picture. This represents this integer, this represents this integer. So the definition is kind of in your face. I can say, okay, so instead of having just a name of drinking action, action is actually just a function that returns void and no parameters. If we go ahead and supply something like a func integer here that returns an integer, I already know this is a delegate that takes no parameters and returns an integer. Okay, and again, just understand func and action are both just delegates. Now, let's talk a little bit about lambdas, because some people think lambdas and delegates are kind of the same thing. And on the high level, if you ever get asked, somebody asks you, what's a lambda? You tell them its high level definition. It's an anonymous function. Same way as a delegate is function as a value, you do not start describing that it's a container for a blah 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 and so on and so forth. You give the high level definition. If they ask you to go lower, you go lower. This is where we're gonna go lower, because if you're sticking around this video, you're probably interested, right? So let's find out. Delegates, right? So these things and lambdas are separate things. Okay, lambda is one of these guys. It's a function. Delegate represents a function. Okay, in reality, delegate is a container in which the function goes. And if that doesn't kind of paint a clear enough picture for you, we're gonna go into a different example here. And here I'm going to try to show it to you through inspecting of intermediate language code and stuff like that. Let's go ahead and bring up let's actually define our own delegate, because that's going to be a little bit more visible. We're going to say integer and get number. So then get number, get n equals no value, or rather maybe parameterless. We'll see what that goes. Yeah, so we're not going to be discarding parameters. It's just going to be an empty, a parameterless call. Okay. And then we can go ahead and call this. And I mean, I don't, there we go. Printing out a 5, right? Nothing special. Let's dissect this. Let's find out what's going on under the hood. I'm going to bust out IL here, and I'm going to try to commentate this as best as I can from what I remember of what these opcodes are when I was trying to understand this myself. And what else I'm going to do, if you're using LinkPad, you can press Alt-Shift-R for full decompilation. That's what I'm just going to press now, and we're going to take a look at the actual module here that is being spat out. And hopefully I can convey the knowledge to you. So it's okay to drop off here if this is of little value when you're actually using delegates, other than maybe performance reasons, but that's not why they exist. They exist to increase your readability. Okay, so here we have the main function, which is pretty much the representation here, right? Which is kind of like what this whole thing is. Let's go to the get number. So this is a delegate. This is the definition for the delegate that we created. base types doesn't matter so much. This is the constructor for it, so I want you to pay attention here. We pass an object to it and an integer pointer. So back when I was showing to you the interface object representation, that's kind of what it is, but not really. I'm going to show you a little bit of a closer look to it in a minute after we get done with this. And hopefully at that point it will paint a more clearer picture of what they are. So then we have begin invoke and end invoke. These two are for if your delegate is asynchronous, and then invoke, which is just call the function. Okay. Then we have this object here. Okay. This object is quite interesting. It looks a little bit funky, and once you unpack it, you understand what it is. But let's step through this one by one. So we have a class, a static field with which basically initializes itself. So it's a singleton, and then we have the get number delegate here. Okay, and then we have a function here. So if we expand it, this is the function that we've defined. So this is this lambda. So even though this lambda contains the delegate, I want you to understand that this class just represents the lambda. The reason the delegate is there, so we don't have to create it again. So it's sort of caching itself. Okay, and we'll see how this cache works through looking at this. So LDS field is we basically take the value of 9_4, which is this field, and we put it onto the stack. We then go ahead and br true, which does something along the lines of if not null, jump to this label here. So it's going to jump there. So this is where I said it's about caching. It's about checking, is this already initialized? If it is, we can skip the initialization process and just go to using it. So here we would skip, although at the beginning it's not initialized, so we take the value off. We then go ahead and get ourselves the object, and then we get ourselves the function here. Okay, so here we get a field, here we get a pointer. These are specific instructions. I mean, you can look them up as well. And then what we do is we go ahead and we invoke the constructor on the delegate. Okay, so the lambda as an object gets passed into there as well as a pointer to the function. So this is where we invoke this constructor, where the object of this C and the function, which is the main function in here, gets passed into there. So the pointer of it. Back, we're gonna get a pointer to the delegate, and we're gonna go ahead and set it to the field. So then we go ahead and initialize this field here. So this is all happening under the covers. Super simple stuff. SDLoc, whatever. In the interests of time, we're gonna go ahead and just then call invoke on the object that was or whatever got allocated onto the stack here. At what's called local variable index 0, then we get the local variable. I like how I say it in the interest of time and then keep rambling on and then go ahead and explain myself why I didn't take the shortcut. Whatever. Let's go. Call virtual invoke. We call invoke, and then we go ahead and call dump and whatever those things do. Okay. So if you didn't understand any of that, let's go ahead and I'm gonna try to sort of reel it back into. I will not be able to use the int pointer there because that's kind of an instruction on the opcode level. I will instead use a method information. So to paint it a little bit more simply, we're going to create my delegate, which is going to have a public constructor. Okay, my delegate. We're not going to put anything in it just yet. We're also going to have a my lambda like that, and what my lambda is going to do is it's going to have this definition here. So public int main is what the function was given, and we're gonna say 5. So this also, for some reason, well, for caching reasons, not some reason, holds my delegate. So my delegate, just like that, and that's going to be null. So in here, what do we do in here? We pass an object and we pass a pointer. So I'm gonna opt in for method info like that. Let me go ahead and drop this down a little bit so you can see it. And then I'm gonna do maybe, is this writer level integration? It is not. Let's go ahead and put this something like this here, method info and info here. And then we can do obj equals obj. And then we can have info equals info. And then we can have our trusty old signature that we define here, int invoke, and here we go ahead and invoke the info invoke, so we pass it along here, and we also pass the object into here. It's also going to have some parameters which we don't have, like that is, let me just conversion, oh yeah, and obviously I gotta do something like that. This is essentially what it is. So what we don't see is we don't see this, these bits here on the delegate implementation. So again, if I quickly open this up, so in here, once we get to the get number, so this is our delegate, you can see how if we look at the delegate itself, we don't see the implementation, and that is because it's given to it by the runtime. It is not defined at compile time. So right now we don't know what it is until it runs. Okay, and this is kind of what it looks like, although this is replaced with a pointer, and quite a similar implementation. So what happens here is we instantiate the my lambda. So my lambda L, just like that. We do a little check if L my delegate equals null. Okay, if it is null, let's go ahead and do the following. We're gonna create a my delegate new my delegate, and in there we're gonna do something along the lines of pass the object into it, and then also what we're going to do, get a type of my lambda here, and we're gonna get a method that, you know, is called main. And let me drop this down on new lines here. Hopefully, I don't know if this adds readability or not, but there we go. We have the delegate. We then go ahead and assign it to the my delegate on the object itself. And the point that I'm trying to demonstrate here, again, it's not important to know this actual implementation. The important thing to note here is this is the gymnastics that happens in the background in order for you to have a more comfortable, more readable programming model. Okay, it's for you to be able to read and understand more quickly. Once you need performance, get rid of it, okay? Because performant code is this is right here. This is not readable, but that's what you write in the end, okay, to make it performant. But anyway, let's go ahead and finish this off. So we can go ahead on the my delegate, we can invoke it, and we can go ahead and dump it. All right, and let's take a look at the result, and the result is still 5. And that is pretty much what goes on under the covers. If you are interested in the particular thing that actually happens to the get number delegate object that is going to be here, right? So you can see the extern keyword. So it's some external implementation essentially. This is usually also used when you provide an implementation in a separate DLL, an external DLL, or basically you have C++ code compiled to a DLL, and then you define its interface in C# code. Let's I wanted to show what's kind of like, where does the delegate inherit from. So if we have a get number delegate, so let's go ahead and bring it down here, get number, we can go ahead and have some functions on it. Okay, and you will see that it inherits from this delegate type. I don't know if we'll be able to see its child or type. It's basically 2 classes, system.delegate that it inherits from, and if we take a look at it, we can see basically like a bunch of stuff inside of here. Taking a look through all of it, is it important? Not really. Can you inherit from this class? No, it's a special kind of class that is used as an implementation for your delegates. You also get a multicast delegate. All right. And again, this is just another class which is used to implement the delegate that you define. And again, you are not allowed to use this class for, define your custom implementations of delegates. So one last important thing to explain to you is a closure, and it will be so much easier to see because you know all this stuff about delegates now and to understand what a closure is. All right, we're going to come back to this example, and what we're going to do is we're going to take integer I, we're going to give it a 5, and then we're going to go ahead and add I. All right, pretty cool. So this is an object, and to this object we're going to be assigning a 5. We can run this, we can take a look at the AL code, so you can see how if this was something like a static function, okay, you can see it's being underlined here. This is kind of like if we had public int I5 here, this is plus I. If we define this to be static, we can no longer use this here, right? So in this manner, all lambdas and delegates they take away the need for you to create this bulkiness of classes and interfaces. It does it for you. All right, so hopefully you understand that closure is this specific thing. It's like putting your variable inside of that function. So let's go ahead and take a look at what the code behind looks like. I'm gonna go ahead and get this thing right here. So let's take a look at the class, and you can see that the I field becomes part of the class, and this is pretty much what a closure is. So if you ever hear someone using words like closure, now you know what they're talking about. Essentially adding some kind of value to the scope of the object where the function is being performed. All right, this will be it for this video. Thank you very much for watching. Hopefully you've enjoyed it. If you did, like, subscribe. If you have any questions, as always, leave them in the comments section. Come ask them on my Discord server. Any other C# specific topics you'd like me to cover, please tell me. I also stream on Wednesdays and Sundays. Make sure to come join for the big lols. That's where it happens. And hopefully I'll see you in my other videos.